Alright, today guys, we went over exponents and powers. I want to put on the lesson up here for you guys tonight so you can look over. Once again, the standard is 6EE 1.1. We pulled it out of the new books, so make sure you're on those books as well. Alright, now I did want to talk about, I didn't do this in earlier classes, but I did it later because I see it was an issue. So everybody does remember PEMDAS, or what is known as our order of operations. Okay, so whether you're talking about please excuse my dear Aunt Sally or something else. But I wanted to point out the E. Okay, everybody knows that P is parentheses, but the E you may not remember, but it was for exponents. Alright? Now, just a simplified version of a definition of exponents. We're talking about a base factor multiplied by itself a certain number of times. Alright, that number of times multiplied is the exponent. Now this is what I'm talking about. So let's say we have a base of, we'll say 3. We have a base factor of 3. So this is what we call the base. Alright, so that's the base. And we say that it is a power of 2. It has a power of 2. Alright, this 2 is the exponents. You guys should remember this from last year, but I do understand it's a little bit hazy. Everybody had a pretty good summer. Okay, so my base factor multiplied by itself a certain number of times is my exponent. So this is 3 multiplied by itself 2 times. So we will write it as, all right, 3 times 3. Now they tell you about decomposing and composing. Alright, and like I told you guys today, it's kind of like an accordion. I want to be able to pull it out and sing, you know, when the moon is short, I like a big pizza pie that's a morning. Right? An accordion. I want to be able to pull it apart, and I also want to be able to compress it like it's a spring. Okay? So for this, our base factor, we expand it out, multiplying by itself. So 3 to the power of 2 gives me a value or a solution or a product of 9. So 3 power of 2 is 9. Alright, this can also be stated as 3 squared. Alright, anytime we have a 2 as our exponent, that is what is referred to as squared. It comes back to a squared, right, like we talked about today. Now, it can go for other problems as well. I do want to talk about our perfect squares. Okay, so if we're talking about our perfect squares, if we take 1 and we square it, that's 1 times 1, which gives us 1. All right, 2 squared. All right, that's not a 2. All right, 2 times 2, which gives us 4. All right, 3. That's not 3. All right, 3 squared, all right, will be 3 times 3, which gives us 9. 4 squared will be 4 times 4, which will give us 16, so on and so forth, down to 10 times 10, or 10 squared, which is 100. All right, these are known as perfect squared. 1 squared is 1. 2 squared is 4, so 4, so 1, 4, 9, 16, they're all known as perfect squares. Alright, now, for cubes, when we say cube, we're talking about to a power of 3. Alright, and think about when you see a cube, okay, think about a cube. We have a square front. Alright, what is a cube? A cube is a square which has congruent sides all around. Okay, but it is a 3-dimensional square. Okay, so it's 3-dimensional. So when we're finding the volume of a cube, we're using length times width times height. Okay, so if my length is 2 and my width is 2, then my height is going to be 2 as well. So when I say 2 cubed, I'm saying 2 times 2 times 2 which, as we talked about today, is not 6. It's 8. All right, remember, Mr. Herman has a problem with that one. All right, that and 3 squared, it bothers me. Okay, so remember that. So if I was going to write out my perfect cubes, all right, my perfect cubes, I would write it as 1 cubed, which would be 1 times 1 times 1, which gives us 1. Let's see here, not 1 again. 2 cubed. 2 cubed, which is 2 times 2 times 2, which equals 2 times 2 is 4. 4 times 2 is 8. All right. 3 cubed, all right, would be 3 times 3 times 3, which gives me 27. 3 times 3 is 9. 9 times 3 is 27. 4 cubed. Let's get down here a little bit because I know I'll start writing crazy. 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 gives me 64. All right. Now, these are what we call our perfect square. These are our perfect cubes. And you'll find some of these do repeat. There is a little bit of a connection there. Okay, now, like I said today, I had everybody write out 1/2 cubed or 1/2 to the 3rd power. All right, and we learned that we had an issue there. So let's write it out now. So I'll write it out as 1/2 to the 3rd power. Now, as we learned today, if I write it without parentheses, this exponent applies to the numerator, and only the numerator, leaving me with an answer of 1/2. If I'm going to write this out properly as 1/2 cubed, I have to have the parentheses. Guys, do not forget your parentheses when doing this. Also know that once I have the parentheses, they stay grouped together. Therefore, I have, in expanded form, 1/2 times 1/2 times 1/2. And like we talked about today, all right, multiplying fractions, everybody that's afraid of fractions, if your parents are afraid of fractions, multiplying fractions is the greatest thing because it's the easiest part. So, all we got to do is multiply my numerators and multiply my denominators. So, as I multiply across, 1 times 1 is 1, 1 times 1 is 1. So I know my numerator is 1. My denominator is going to be 2 times 2 is 4. 4 times 2 is 8. So now I know that 1/2 cubed is 1/8. Okay? Things to remember today, guys, when you're doing the homework. If they ask it in decimals, I want the answer in decimals. If they ask it in fractions, I want the answers in fractions. All right? Make sure to, if they're asking for expanded form, you're giving me expanded form. And if they're asking for the solution, give me the solution. I think we covered about everything in class today. I hope you guys enjoy this. I know a lot of people were taking a picture of this earlier today, so at least it's online now and you guys can find it. All right, and that is, I have the power.